After you and your teammates have created all the parts in Onshape based on the CAD drawings, you have the base, the leg, the waist, the upper arm, lower arm, and wrist. Make sure you've renamed all the parts as well, so that way it's easier when doing the assembly. Before you can create the sub-assemblies, you'll need to download the compressed files of all the parts that came from somewhere on the internet that you don't have to redraw yourself. To do that, you'll be able to go pull the robot arm import parts from Google Classroom and save it to a certain location. To download it, you'll actually need to click the menu button and say open a new window, and then download. And you can save these into the download folder or some other folder on your computer that you know how to find. Once it's done being downloaded, I can say show in folder. And then I want to extract them. So to do that, I right click on it and say extract all. That's fine. Give yourself a location to extract it to. And once they're extracted, you'll see a number of step files that will import into Onshape. Just remember where you extracted it to. So for example, I extracted to downloads. So if I go back to Onshape, I'm going to click the Insert New Element button and say Import. And then go to my Downloads folder. It's the other Downloads folder. Yes, your computer may have two downloads folder, one for the username and one for the default user. So it can be kind of confusing at times. There it is, Car Robot Import Arm Parts. Now I can just select them all and open. You can say import into this document or combine into Part Studio. It really doesn't matter either way. And then we'll check back when it's done importing. It may take a few minutes. Once it's done, it should say translation complete, and you should now see the items show up in your list. We have the 40-tooth gear, the stepper motor, the micro servo motor, a gear rack if you want to use it later, a servo horn, the 20-tooth gear, and the 10-tooth gear. After importing the parts into your main robot file that you share with your teammates, now each teammate can use these parts to create assemblies for the second part of the assignment. To create the base subsystem assembly, we're going to create a new element, create assembly. I'm going to rename that assembly base subsystem. Then I'm going to insert the parts I need. And I can find those by looking in the current document Part Studios. So I need the base, 2 legs, and the waist. I'll need other parts later, but I'll bring them in after I'm done this part of the video. So first thing we're going to assemble is the legs to the base. And when assembling the base, you want to make sure that when looking at it from the top, the holes on the bottom are farther apart than the holes on the top horizontally. Otherwise, you're looking at the other side of it. If you're looking at it this way, you'll see it differently versus this way. So the first thing we're going to do is a fasten mate. So we click fasten, and we're going to click the bottom of one of the legs. So I get the handle that shows up in the center of the rectangle. So I might need to roll over the edge of the surface so I can see the blue alignment tool perpendicular to the face of the rectangle. And I'm going to click the same alignment area on the bottom of the base. If you click the roll over this, hover on the surface, and then you can click on the center of that rectangle. There. Once clicked, you can see it inserts it and aligns the blue edges up. You shouldn't need to rotate or flip. If it's good, you click OK. And I'm going to do the same thing again for the other one. You always have to click the part that moves first versus the part that stays still. Seems to highlight it red. I might need to do it again. Sometimes it has an error, it says. Let me double check. Sometimes I find it gives weird errors, and if that's the case, you can always delete and do it again. This time we can show how you can do it from the center rectangle. It really doesn't matter which rectangle you use. And there, that snapped right together. So we click OK. And do the same thing to the other one. Fasten. I called this the foot, I think, in the instructions of the leg. And just make sure you line the correct rectangle up on the base. If you click flip directions, it's going to put the piece on upside down, and that you don't want that. If you need to, you can do things like change the offset, so you can adjust it up or down or left or right, but it should align it correctly if you click the right spots. Now I'm going to basically do the same thing with the waist onto the top of the legs. So fasten. I'm going to click the top. I'll hover on the top surface of the rectangle of the leg first, and then click the center point. And I'm going to orient it so that the motor notch is facing the inside of the base. So I'm going to want to zoom in and make sure I hover over the flat surface on the top so I can get the handle to grab. Sometimes it's difficult to do, and you might need to change the angle of your view so that you're unable to select other surfaces. Click here. It snapped it over there. Because it can only handle 2 parts at a time, remember to say solve to show it in place, and we say OK. Now it should be locked in place and I can't move anything. Now I'm going to go ahead and fix the base so it can't move. Now I want to insert the stepper motor. Insert, choose it from the list. Click OK to the insert tool. Now I can't assemble it just yet because if I click and drag on the pieces, I can see I can actually take it apart, which is what we don't want to do. So don't do that. We're going to select everything with a window select of the stepper motor, and then we're going to click the group command and OK. And now if I try to separate it, I can't separate it like I could before. Now we can work to assemble it in the right spot. I'm going to use the fasten tool and try and line up the circular hole for the mounting bracket in the motor to the hole in the waist, and then adjust the angle until the faces are parallel and the holes line up. Unfortunately, I don't think our dimensions, since the waist is in inches and the stepper motor is in metric, the distance from center to center on the holes doesn't match perfectly down to the micron, so it won't let you do a 2-hole assembly on it. So we're going to say fasten. I'm going to click the top of the mounting hole in the waist for the stepper motor. And then the underneath side of the corresponding hole on the stepper motor. Sometimes you need to change the angle to grab the handle you want. There it is. And so I'm first going to zoom in and make sure the offset Z height is correct. So it's sitting on top of the waist. It looks like it is. And then I may need to reorient the second axis. And I can get to that menu by clicking the offset command. Now we want to offset around, or I'm sorry, rotate about the Y axis. And it should be within 45-degree increments. So first we'll try 45 and hit tab. Oh, that looks like it's the wrong axis in this view. Let's Control Z, undo that. We want to rotate about the Z axis. I'm sorry, I had that wrong. We want to rotate about the blue axis. That's what was Z. So let's try 45. There, it looks like 45 degrees did it. If 45 degrees didn't do it for you so that the holes line up, you might need to go 90 or 90 plus 45 and kind of just guess at the increments. And so we say, okay. There is a small error in the file in that this particular stepper motor I downloaded online does intersect our model a little bit here. And when you go to assemble it, we'll have to just kind of file off or use a little bit of sandpaper to sand that piece out. All right, so now we're done with the main assembly unit. Next, go on to the base subassembly part 2. Now that you have the base section assembled, you want to use the Insert Standard Content feature. Insert Standard Content. to bring in screws and nuts to make the assembly more realistic and to keep track of the number of parts you need. So you're going to choose ANSI inch, bolts and screws, machine screws, and for this purpose we want panhead machine screws, size 440, PH for Phillips, length 0.5, thread length is 0.5, and so we say insert. And we actually want 8 of them. But I'll just insert 4 for now to finish the operation. So they're going to go in the holes for the base. So we can just use a fasten mate. And you're going to click the underside of the screw head where the kind of the handle shows up. And they will go along the same alignment hole on the bottom here. And if they show up backwards, just flip primary axis and check. So we'll do that a few more times. Put these on this side. Must not clicked it on the other one. There it goes. And they're in place. One way to determine the right length of the screw is to use the details feature. So to use that, we can click it and we can click the top surface of where the screw head would attach to, and then the bottom surface of where the screw would run into. And we can see that distance is Z, just over 0.5. 0.516, or if we remember in our directions, I believe it was 17/32, so it's just beyond half an inch. So we know that a 0.5 screw would fit. So now we need to put a nut on the screw. So insert, standard content. This time we're going to choose the nut selection, machine screw nuts. We want hex machine nuts, and our size, of course, is 440. And if you click the bottom chamfer, it'll look like the ones you actually used in your assembly. So we say insert. I'm only going to insert 1 and then show you, actually I'll insert 2 and show you a feature way to duplicate it. So we're going to put the nut on this screw here. And the way to figure out how far to offset it is we can use that show measure feature again. So we want to know how far it is from the face of the top of the waist to the face the nut would rest against if you tightened it down, and it says a Z depth of 0.313, which is actually 0.3125, and that's 5/16. So now I can use fasten. Pick the top of the screw head as always, making sure the handle's highlighted, and then I'll click the handle on one side of the nut on the top side, and we can see it put them together face to face, and so I want to offset that Z distance 5/16 or 0.3125. I can click tab to see it in place, And it looks like it's the right depth, but we can see the nut is turned 45 degrees off. So we're going to rotate it so that it sits with the flats against the flat here. We can click OK. And so now it looks like it's in the right spot. These nuts are a little bit bigger than the ones we're using in class, so they actually don't quite fit, but that's okay. Now you could do that over and over on the other instances, or we can also use replicate. And so what replicate allows us to do is select instances. And so if we want to replicate the screw and the nut, you click match face to parts, or you can click face to features or individual faces and do it one at a time. If I say match face to parts, and click the top surface of the waist, you can see it replicated the screws 4 times. And I can click OK. It actually did it twice over here, so I now actually have 2 here on my previous instance, so I probably shouldn't have done that and shown you this trick first. So if you need to, you can just go delete it. I'm not too concerned. That was the first one we did, so I can go and delete that. And then I can do the same operation on the bottom after I install the nut on this particular screw. It doesn't work to do replicate well when you're changing orientations of a part because they show up upside down and they're kind of difficult to get turned around. So we'll just click fasten again, fasten the screw to the nut, make sure to click the correct side of each piece so that when you do the offset, it's the correct distance. 5/16 offset. That looks right. I need to reorient the second axis to spin the nut around so the flats are against the flats. Click OK. That's good. Since I'm going to use replicate again, I'm going to go ahead and delete this one out of here. Replicate. Select the screw, select the nut, match edge to face, find face match, so click the blue box. And I'll highlight the face and it'll go ahead and replicate these. Sometimes it'll go ahead and do these holes too, but it shouldn't because they're a slightly different size. All right, that looks appropriate. And we click OK. And there we go, it's all done. Now, if you don't want to see those handles, you can just say hide mates. They show up on the pre-inserted parts. So we can select them all and hide mates. It looks like they're still on the nuts though. Oh well. It's got so many mates in there because of the replication. It's hard to turn them all off. All right, now that you have screws on both the top and the bottom, we have one last screw to insert, and that is an 832 length. Insert standard content. Since I've already got the nut selected, we'll go ahead and insert a nut. We're going to use size 832. Insert. So this is a larger one, and it's going to go in this hole here. And we actually need the 440s for these 2 screws here as well. So I'll go ahead and put those in while I'm at it. So for this screw, we want 832, and we want 1.5 inches. So length 1.5, thread length 1.5, insert. Now we're going to insert the screw here and put the nut on top. Fasten, screw will go underneath in this hole here. Flip primary axis, and we'll say check, and then we put the nut on top. And the offset on this one will be 1/8 of an inch. Sometimes you need to do negative 1/8 of an inch to get the offset the right distance. All right, there we go. I'm not going to show you how to do the assembly on these 2 screws because you can do those on your own. Having done all the other ones, you don't need help now. To create the upper arm assembly, we'll first create a new assembly and label it upper arm subassembly. Then we'll insert the upper arm into the subsystem, the 40-tooth gear, and the micro servo. First, we'll fasten the servo into the slot in the upper arm so that the hub of the servo is on the left side of the upper arm, farthest away from the center mounting hole for the gear. The servo will be mounted in the upward position on the underside of the arm. So to do that, we're going to click Fasten. And I'm going to grab the alignment handle for the hole that's on the farthest left side of the arm. And then the top side of the alignment handle on the servo as well, on the side that has the hub. If you're not careful, when you go to click the alignment handle, you'll grab the wrong alignment handle. So zoom in and make sure if you roll over the center of the face, is not the same as the center of the circle. So you want to roll over the edge of the circle to grab that alignment handle. Once I clicked, it pops it into place, and then I can reorient secondary axis to spin it around. And once spun around completely, it shouldn't have any intersections on the in between the servo and the body of the upper arm, and it just should be flush with the servo in the upper arm. We say OK. So now we can see the servo hub is on the far end of the arm. To do the gear, we're going to do a fasten mate. And I'm going to do the flat side of the gear. So this side at the center hub alignment. I didn't actually click it. There we go. And that's going to go on the 3/16 hole that's farthest away from the servo. And so it mated the two together. We don't want them intersecting like that. So we want to flip primary axis. So now that the one's upside down. And then I'm going to rotate it so that this hole lines up with that hole. There you go. So the 2/16 holes line up. Don't worry about these two holes here on the end. They're small holes for a zip tie for tying the wires down, which won't happen in this version, but it will happen in the real assembly. So we'll have to kind of pay attention to that as we screw it together. If I get the alignment I want, I can click OK. Otherwise, you might need to use the offset angle tool to change the rotation of the gear to get it to line up. All right, once it's done, it should look like this. Now we can complete the upper arm subassembly part 2 using standard content. So first we'll insert standard content, ANSI inch, bolts and screws, machine screws, pan head machine screw, and we want a 632. Phillips head, and our length will be 1 inch. A smaller screw works, but we'll be using 1 inch in real life, so that's what we'll use in our example. I'll place the screw, and then I'll go ahead and grab the nut while I'm at it. So ANSI inch, nut, machine screw nuts, hex machine screw nut, size 632. And you can check bottom chamfer. Insert. While I'm in the menu, I'm going to go ahead and grab 2 of the screws for the servo as well. Cancel adding in the screws yet. I'll show you a new feature in just a second. So we're going to mount this screw to this hole here on the underside. So we'll turn everything over into position. Oops. Fasten. Click the fasten handle of the screw. And then on the mounting servo head, flip primary axis. On the gear, so that the screw is facing up. Click OK. Now we need to do a measurement to figure out how far apart to make the two. So exit out of your menu and use the show measure details, and we're going to go from the flat surface of the gear to the top of the face of the upper arm, and it says it's a Z distance of 0.417323. We'll just do 0.417, it's fine. So fasten again, and I will click the handle to the screw since that's flush to the face of the gear. And then the bottom handle on the nut. Remember, it solves it outside the system, so you've got to say solve to see it in place. And that's obviously inside our part, and that's not what we want. We said we wanted an offset of 0.417. Tab to visualize, solve it again. Now it looks like it's approximately in the correct position, which works for our purpose. And check to say okay. Ignore the part where the nut or the screw intersects the gear pieces. This gear model is not 100% accurate due to the complexities of trying to do a rounded edge of the gear, so it's a little bit inaccurate and won't intersect in real life. Now we can insert screws into the servos. So we're going to say insert, standard content. They don't have the exact right screw, unfortunately. ANSI inch, bolts and screws. This time we're going to use tapping screws. Panhead tapping screw is fine. And we want to use size 2. Slot, all this, the rest of the stuff is fine because we can't edit it what we want, how we want to edit it. So I'm going to say insert. And now they're a little longer than we need, but just because of the purpose of the activity, we'll continue to use them. Because they have an automatic handle attachment to them, we can actually insert them into place. If you zoom into your location and kind of find the circle you want to use and hover over it, it'll snap into place. And I can automatically insert them in the right spot. Ignore the fact that they stick up too far in this particular model. And so I can say insert again. Kind of rotate my screen to get it where I want. So I might need to zoom out really far and zoom back in. And as I get close to a handle, it'll automatically choose a circle hole where they're going to go. And now that they're already inserted, we can just close out the insert menu. Nope, it looks like I inserted one too many. All right, there we go. And if you want to turn off the little insert handles that show up on your screws, expand the screw menu and turn off the eye for the near and the far attachment points. All right, there you go. Your upper arm assembly is complete. To create the lower arm subsystem assembly, we'll first need to create a new assembly called lower arm subsystem. Create assembly, and then we'll rename it. Then we'll insert the lower arm, the S51 micro servo, the wrist, and servo horn. First, we'll fasten the servo horn to the lower arm so that the short end of the servo horn is aligned on the right side of the arm, and the long end of the servo horn faces where the wrist mount will be. We'll fasten, and we'll use the top surface of the servo horn at the center hole, and then mount that to the bottom of the arm. Make sure you grab the bottom. On the face so that the circles line up. And I'm going to want to flip it so it's on the bottom like that. And if you need to rotate it around, you can do that, but you want to make sure the long end points towards the holes for the wrist. And when you're viewing it in isometric, the servo horn's on the bottom and the wrist mount is on the left side of the arm towards the back edge. Okay to confirm. Now we'll attach the wrist to the arm. Fasten again. And this time we'll line up the protruding rectangular shape on the bottom of the wrist, just using the center mate constraint for it. And a similar rectangle on the bottom surface of the arm. So hover over the surface and then grab the center point with the blue axis facing through the arm. We'll click. And that snapped it into place. And it should be oriented so this big tab faces towards the outside of the arm. Now we'll insert the servo through the left side of the wrist so that the servo hub is towards the bottom of the lower arm. Fasten. And so I'll align the hole on the wrist that mounts the servo to this tab that corresponds to that same side. And make sure you grab the circular shape and not the circular with black white lines on it. That signifies the center of this rectangular surface, not the center of the circle. If you roll over the edge of the circle, you can probably also grab the handle. Click to confirm. Remember to say solved, so it switches it back over into place. And that's going the other way. So we want to flip primary axis. Solve again. It's okay, it's turned upside down right now. We can just rotate it back over. And now we want to reorient secondary axis so the servo is extruding through the rectangular shape it fits into. And then solve again. And it should look something more like that when you're all done. And click OK to confirm. That finishes part 1 of the lower arm subsystem assembly. For the lower arm subsystem assembly part 2, first we'll insert 440 machine screws, length 0.375. Insert, standard content, ANSI inch, bolts and screws, machine screws. We want a panhead machine screw, 440. Phillips fine. Length we want 0.375. Thread length can stay at 0.375. We'll insert one of these. We'll actually do it twice, but we'll show you how to do the secondary insert later. So I can insert it manually and do the assembly first. Fasten. Click the handle at the face of the underside of the screw. And then it can be inserted into the underside of the arm in the corresponding hole that goes to the wrist mount. That looks right. And if we zoom in, we see the surfaces don't touch. We can click OK. Now I can do it again, but I can also, if I choose everything correctly, click Insert, and it automatically inserts with the handle identified. So if you want, you can kind of actually roll over where it's going to go. Click OK to insert it in that location, and it'll automatically include the fasten mate to that content. Now we can insert the 440 nuts. Insert, standard content. Sometimes it'll say FCPS blocks it. You can just click insert again and it'll work. Bolts and screws, but change that to nuts. Machine screw nuts, hex machine screw nuts, size 440. Insert. And if you notice, it has the handle line up, show up already. So if you're careful, you can kind of highlight where you want it to go to insert it into place. But first we're going to measure where it's going to go instead. And since they have to be offset, it's a little more complicated, so I'll just insert 2 of them and then install them in place. So to figure out how far we need to offset, we're going to measure from the flat surface on the bottom of the T-nut shape to the flat of the bottom of the arm. I don't think I clicked it the first time. And it says it's a distance of 0.25. So that's how far our offset will be. So fasten, click the insert handle for the screw and the bottom insert handle for the nut. It moves it into place. We want to say solve so we can visualize it. Click the offset option box and change it to 0.25. Solve again to see if it works. You might need to click solve 2 or 3 times so that it puts it into place. Now we need to rotate or reorient secondary axis to spin the nut around so that the flat of the nuts line up with the flat of the T-slot. There we go. Sometimes it takes a little while due to the lag on the computer. Click OK, and we'll do it again for the second one. Now we'll insert small tapping screws to attach the servo horn to the arm and the servo to the wrist. ANSI inch, bolts and screws, tapping screws. Panhead tapping screws are fine. And we'll say number 2. Again, they look a little large, but they work for our purpose. Don't worry about the fact that they extrude a little bit too far. So we can say insert. And since these automatically have a handle selected, again, you can roll over the surface and they're going to go down through the lower arm into the servo horn. So we can kind of line them up on that hole. Click to place them and it'll insert them automatically. If you want to do it separately, you can insert it and then use the fasten technique. Click the handle for the screw, the alignment handle for the part, flip as needed, and complete it that way. We're going to put 2 here on the servo horn and 2 on the servo. These will go on the back side of the servo. So the screw head faces through the wrist and screws into the wood. I'll do another one on the bottom. In real life, they won't stick out quite as far as they do in our example because the screws we're actually using aren't available in Onshape. So we have our 2 screws attaching the servo to the wrist, and then the 2 screws attaching the servo horn to the lower arm. And that completes the operation for the lower arm. Now that your group has worked together to assemble the various subsystems, we can use those subsystems to create a final assembly. The reason why we use subsystem assemblies is because the subsystem components, when inserted into the final assembly, should remain whole, and it will have less effect overall on moving parts. So we'll start a new assembly. Call this robot final assembly. And then we'll insert our assemblies, the base assembly, insert the lower arm subsystem, and the upper arm subsystem. And then we need the 20-tooth gear as well. Oops. Make sure to click OK and not close the box out like I did. So first we're going to attach the 20-tooth gear to the stepper motor. We can do that using a revolute mate. and we'll attach at the bottom of our gear so that we grab the handle in the center of the gear to the top of the stepper motor. And we're going to flip primary axis so that it mounts it kind of in an upside downward fashion. And then we can adjust the offset if need be, but it doesn't look like the gear actually intersects with the base. Looks like it'll be okay. So we click OK. And that's good. And so since we used a revolute, well, it'll be able to spin later. We're going to want to go ahead and close out of that. We'll fix the base so it stops moving. And now we can spin our gear. Now we'll put on the upper arm through that gear on this screw, and our gear should mesh in real life. I don't believe they mesh correctly on the program. So revolute mate. Again, we'll select the bottom of the gear where the center hole is. And we'll try and get the center mounting hole or center alignment hole for the nut so that those two surfaces touch each other like that. And in theory, the gear should be a little bit higher than the previous gear. And the gear shouldn't intersect any of the screws. If it does in real life, we can just adjust that nut a little bit as needed. We need to see it in working, so we say solve, and that brings everything else over here. We'll go through and attach limits in a little bit. Confirm that. And then we can click and drag it and spin it around. I'm just going to rotate a little bit so we can see that in real life our gears will be the correct distance apart, but these gears ended up being a little bit big after they've been catted, and so they intersect each other. Now we'll attach the lower arm to the upper arm. It doesn't matter the orientation of the lower arm since we're going to move it around. So we're going to do a revolute mate using the inside of the servo horn, the inside circular surface of the servo horn, to the top peg of the servo on the upper arm. So when it inserts it, you're going to want to do a flip primary axis so that it's pointing down. Solve it so that you can see the arm in location. And that looks right. Ignore the screws protruding out. Now this arm should be able to swing back and forth. To establish the limits on the servo, we're first going to complete the lower arm limits, and then we'll do the upper arm limits. To make it easier for parts moving around so much, fix the upper arm section, so now only the lower arm section can swing back and forth. Now we'll double click the mate that attaches the upper arm to the lower arm. And you're going to need to figure out where a relative home position might be, where the arm is extended fully out, something similar to the example. You can click play, you can see the servo moving around. Now we're going to establish limits, and we're going to try negative 60 and 60, hoping this is the current home position. All right, now if we've solved it, we should be able to click and drag, and you see it can move 60 degrees in that direction and 60 degrees in this direction. And if that's good for you, you can go ahead and click OK. If not, you can adjust these numbers so that it swings about 120 degrees in front of the upper arm. It doesn't have to be perfect. Now we'll unfix the upper arm and complete a similar operation. Sometimes it's hard to figure out where if you right click on the arm before you select it, you should be able to say unfix. So now we're going to click the mate we used to attach the upper arm to the waist and set its limits. Its current position will work sufficiently for this, and so we'll go ahead and give it a try, negative 60 and 60. Don't worry about what the lower arm does as we move. So it looks like if I click solve, it switches it around to this position, which is its natural 0 degrees position. And so that's not going to work if I click and try to drag it. I really want kind of 180 degrees after that. So 60 plus 180 degrees would be 240. And 60 below 180 degrees, we can try 120. And there, it looks like that works. So it'll be able to move from this position to this position. The goal being that this servo here doesn't collide with the waist section. Really, this movement actually can exceed 240 all the way around to about 315, I think. There, it looks like 315 will just get it to where the servo doesn't collide with the waist. These servos only have a degree movement of about 120 degrees, whereas the stepper motor will be able to spin continuously in either direction based on what numbers are fed from the Arduino. So we can click OK, and we have completed the first part of the assembly aside from adding standard content. Now we can go ahead and add standard content. This part's not necessary, but it'll help us with the understanding the actual assembly of the real arm. So the first thing we're going to do is insert a washer from standard content. Again, if it says Fairfax County blocks it, just close the menu and try it again. It should show up the second time. ANSI inch, washers, type A plain is fine, and we want a number 8. insert. And there it shows up. And so we're going to insert it so that it's on top of the upper arm on the screw here. If you're lucky enough to place it in the right spot, you can click OK. Otherwise, you can place it out in the open and then move it to the correct location as needed. Now we're going to insert 2 nuts on top of that are size 8. Standard content. Change from washers to nuts, machine screw nuts, hex nuts, 832. Insert. Give it a minute to catch. All right, that looks like that's going to work. It looks like it's going to try and put it below the washer. I don't want that. I think that's in the right position. There we go. That looks like that worked. If not, you can always place it off to the side and place it manually and add an offset. Again, I'm going to insert another one because technically we're going to do this twice. And I'm going to change my angle and zoom in so it's easier to grab the right handle I want to place it on. There we go. In real life, we'll use 2 nuts, but we won't tighten them down very much, and we'll tighten them against each other so that this will spin freely, but won't be able to spin the nuts back off, and it won't be able to move up and down the screw shaft. All right, the last thing we're going to put is we're going to put a screw in here that is a size 0 tapping screw. Standard content. Change from nuts back to screws and bolts. Tapping screws. Panhead tapping screw. And we want a number 0. I'm going to place this one off to the side since it's a little bit hard to kind of get in that hole to place it. There we go. And it's awful small to see. So we want to do a revolute or a fasten mate should work okay for this. So fasten mate, click the handle of the screw, zoom in and click the top surface of the servo horn. And so it should place the screw in there. If you need to flip it around, you can. If it looks like it did okay, you can go ahead and click OK. That's, again, not necessary, but it's more for our purposes to know what screws we're going to need when we do the real assembly. All right, and that should be it. If you want to turn off the handles that show up on the screws, you can expand them in the instance menu and turn off the near and the far identifiers. If you need them again when you're doing an assembly later, you can always just turn them back on. There you go. And that is the robot arm done. Before we start our design modifications, being able to move it back and forth. And once you're able to program it in Arduino, you'll see how what we learned in Arduino is assistive to the project.